Hi students, so welcome you all. So tell all your friends to join our as much as possible early. So today I am going to solve some another two theorems which are very important. I feel that all of you are understanding the theorems. So let us start today's third theorem. Sorry, today's first theorem, that is yesterday's continuation. So it will be our today's third theorem. Okay, so welcome you all. Good evening to everyone. I think all of you are very much fine and healthy. Tell all your friends to join as much as early possible. Subscribe my channel and click the bell icon for recent or current updates so that you can get all the notifications of my classes. Okay, so all of you make the subscriptions of this particular channel. Just you click on the subscribe button and the bell icon so that you will get your what notifications whenever I am going to come live. So today there are only 14 students. Tell all your friends to join as much as early possible. Good evening Anand. Good evening Sanjeev. Good evening to everyone. Okay, so let us go to today's theorem, that is derive the equation of derive the equation of plane derive the equation of plane in normal form plane in normal form, both in vector and Cartesian form, both in vector and Cartesian form. Okay, so here you first see one very important thing. To remember the normal form of the theorem, first you draw the diagram. Next, you remember that in the normal form of the plane, you have the distance from the origin. This distance from the origin is given. So this is very important. Please remember this. Normal form of the plane means this is normal form of the plane. So in that, this perpendicular distance from the origin is given with d. Okay, so whenever you are solving the normal form of the plane, you just remember that this particular length is very important. Okay, so please remember that and make a note of this. So whenever you draw this diagram, you just draw this perpendicular distance from the origin, and that is vector ON. Here the distance is d and the direction is from n cap. This will be given, but not in theorem. In the theorem, you have to write it on your own. You have to write it on your own. But in problems, they will give this, the distance of the plane from the origin. Okay, so please remember that. Here vector ON is d dot n cap. D is the distance from the origin and n cap is the unit vector in the direction of ON. Are you clear? Okay. So now let us go for the diagram. I will write the explanation of the diagram. Hi Yamnappa, hi Sachin, hi Muttappa, hi to everyone, and good evening to everyone. Welcome to the class. Okay, now I will explain my diagram. That is, let phi be the plane, let phi be the plane which is at a distance of at a distance of d from the origin, from the origin to the point n, to the point n on the plane, to the point n on the plane. See this, to the point n on the plane. Clear? On the plane. Clear? So now here vector on will be equal to d dot n cap, d dot n cap, where d is distance, where d is distance, and n cap is unit vector, n cap is unit vector. Okay, so now from this we can see that here vector on is perpendicular to the plane. That means it is also perpendicular to vector np. Say this. This is the vector np. It is perpendicular to vector np. On is perpendicular to vector np. So it implies what? Quickly tell me. Vector on is perpendicular to vector np. Then how can you write this? Quickly tell me. That is vector on dot vector np equal to 0. Vector on dot vector np equal to 0. So here vector on is n cap dot d. So np is op minus on equal to 0. OP minus ON is equal to 0. What is ON? ON is D dot N cap. OP is vector R. ON is again D dot N cap equal to 0. So this much you are going to get. You multiply the terms, that will be D dot N cap into R minus D into D is D square dot N cap dot N cap. N cap dot N cap equal to 0. Okay. So here you can see N cap dot N cap will be 1 and D is common. Take common, make it 0. Therefore, this implies N cap dot R minus D will be equal to 0, because here N cap dot N cap becomes 1. D is common, take D outside and take on this side, it will be 0 by D, that is 0. So therefore you can write it as N cap dot R equal to D. Therefore N cap dot R equal to D. This is your vector form. This is your vector form of the plane. Take it as equation 1. So quickly reply me everyone. All of you, are you following my concept? Are you understanding the theorem? And also tell me how many of you are preparing. Please don't leave. Okay. Please don't leave the preparation. You have to do the preparation as much as possible. Clear? Read and read until you finish your exams. Then only you can score. Okay. Otherwise, it is going to be very, very tough. So please tell me how many of you have understood this? Okay. All of you are telling as yes. So that means I think that all of you have understood this vector form of the plane. Now I will go for Cartesian form. Okay. So before going to the Cartesian form, okay. So now I will go for the Cartesian form of normal form of the plane. See that to solve your Cartesian form, to solve your Cartesian form, the equation of vector form is very important. That is vector r dot n cap equal to d. Here vector r is equal to vector op, that is xi cap plus yj cap plus zk cap, and n cap will be equal to li cap plus mj cap plus nk cap, where L, M, N are the direction ratios, where L, M, N are the direction ratios. Direction ratios. Sorry, not direction ratios, direction cosines. L, M, N are direction cosines. That is direction cosines. Okay. Now replace the vectors in vector form. Replace the vectors in vector form. That is vector r dot n cap equal to d. R is what? Xi cap plus yj cap plus zk cap. Dot with n cap is li cap plus mj cap plus nk cap. That is equal to d. Okay. So now from this you can multiply the terms. That will be L into X plus M into Y plus N into Z equal to D. This is your Cartesian form. This is your Cartesian form. Okay. So hence this is your Cartesian form of normal form of the plane, and here is your vector form of the normal form of the plane. So here the very important thing is, in the normal form of the plane, vector np is perpendicular to vector on. Vector np is perpendicular to vector on. That is very, very important. So all should you remember that. If you remember that, you can write on is perpendicular to np, on dot np equal to 0. So on dot op minus on will be equal to 0. Replace the on terms. Therefore, that will be n cap dot r equal to d. That is your vector form of the plane. So after vector form of the plane, come to Cartesian form of the plane. Replace r n in the vector form. To replace r and n in the vector form, if you replace that, that will be lx plus my plus nz equal to d. That is going to be your Cartesian form. Hence, this is your theorem. Okay. So please, all of you tell me, have you understood the theorem? If you understood the theorem, then I can go for the next fourth one. That is, derive the equation of plane perpendicular to the given vector and passing through a given point. So quickly tell me, all of you understood this? So many of you are not attending today. Why they are not attending? Give me the reasons. How much you not attend the classes, that much difficulties you are going to face in the exam. So please remember that. Please be regular to the classes. Most of you are not attending the class. Why they are not attending? So please tell me the reasons. So I want to know the reasons. Some of them are not attending the class. His time is correct, 7 o'clock. Now you are not going to attend any classes. You are going to be free in the home. So that's why I am making this at 7 o'clock. Okay. So in the evening, all of you will be free and also all of you are going to be fresh. So that's why I am keeping the class at 7 o'clock. Then also you people are not attending the class. What is the reason? Please give me the reasons. Why your friends are not attending the classes? Okay. Now I will go for derivation of the equation of the plane. Derivation of the equation of the plane when the perpendicular to the vector is given. Perpendicular to given vector. See here, this is the given vector. Okay. So this is the given vector perpendicular to the plane. Okay. So here vector is perpendicular to the plane, and using that you have to find equation of plane in both vector form and Cartesian form. See, this is the perpendicular vector to the plane and it is also passing through the given point. Here point A is given. Okay. So these two terms are given. One is perpendicular vector to the plane. Another one is point. Okay. Plane is perpendicular to the given vector and passing through the given point. So using that we have to solve our theorem. Okay. So now see here, plane is passing through the given point A and OA is the position vector of OA is position vector of the point A. OA is the position vector of point A and OP is position vector of point P, where P is arbitrary point. So now we shall write the explanation of the diagram. Now we shall write the explanation of the diagram. Let phi be the plane. Let phi be the plane passing through given point A and perpendicular vector n, passing through the given point A and perpendicular given vector n, where ON, we shall write not ON, OA. OA is the position vector of point A, where OA is position vector of vector of point A, position vector of point A, and vector n is perpendicular vector, perpendicular vector. Okay, so here you can see that vector n is perpendicular to the plane as well as vector AP. Vector n is perpendicular to vector AP from the figure. From the figure, you can see this. So therefore, this implies n dot AP equal to 0. N dot AP equal to 0. So that is n dot OP minus OA will be equal to 0. Now, vector n dot OP is R minus OA is vector A equal to 0. So this is your vector form. This is your vector form. And take this as equation 1. So all of you quickly tell me, have you understood this? All of you quickly tell me, have you understood this? So Sushant is telling that he has understood the theorem in the vector form. What about the others? Okay. All of you please reply. Anand is also telling yes. Veena is also telling yes. Lakshmi is also telling yes. Very good. Okay. All of you are telling as yes. Very good. So my dear students, so if you have any doubts, if you are feeling very depressed in the lockdown days, here you can ask what all doubts you have. So you can also tell me the difficult concepts or the difficult chapters that you want. Sushant want to complete the video very soon. No problem, I will go forward. But before that, please tell me what all tough chapters I has to revise after the completion of 3D geometry. So now I will go for Cartesian form. So before going to Cartesian form, you must know vector form. That is vector n dot vector r minus vector a equal to 0. So here first you write vector n, that is ai cap plus bj cap plus ck cap. Next you write vector r, that is xi cap plus yj cap plus zk cap. Next you can write vector a, that is equal to x1 I cap plus y1 j cap plus z1 k cap. Okay, replace all the vectors, replace all the vectors in vector form. Therefore that will be vector r minus vector a dot vector n is 0. So here r minus a, simplify r minus a, xi cap x1 I cap, that will be x minus x1 I cap plus y minus y1 j cap plus z minus z1 k cap dot with what is n, that is ai cap plus bj cap plus ck cap, and it will be equal to 0. So these all things you have to write. These all things you have to write, and the explanation of the diagram is also needed. Here, explanation of the diagram is also needed, and here this is also needed. Okay. Now you solve the dot product, that will be a dot x minus x1 I cap plus b dot y minus y1 j cap plus c dot z minus z1 k cap will be equal to 0. So this is your Cartesian form. This is your Cartesian form. And here is your vector form. So like this, you can write your theorem where plane is passing through, the given point and perpendicular to the given vector. And the third theorem is normal form of the plane. Normal form of the plane means you have to take vector which is at the distance of d from the origin, and here in the fourth theorem, vector n will be the perpendicular vector to the given plane. That is only the difference between normal form of the plane and the plane passing through the given point and perpendicular to the given vector. All of you understood these two theorems? Quickly tell me. So we have completed 4 important theorems, and next we should go for the fifth theorem, which is not in your syllabus. So here the fifth theorem is not in your syllabus because to solve the fifth theorem you need one very important thing, that is scalar triple product. Scalar triple product, and this is deleted, okay. So 99.9% they will not ask this. They will not ask this theorem, but 0.1% they can ask. So for this, try to solve it on your own. So I will give this as homework for all of you. So I don't say that they will not ask this in your exam. There is 0.1% of chances of asking. Okay. So that's why I will give this as homework. So try to solve this before going to the exam. Okay. So now we have completed our 4 important theorems for your Karnataka board exams, and we have completed our task of 5 mark. So that is this 5 mark task is over. Now next I has to go for 2 mark and 3 mark problems. 2 mark and 3 mark problems of 3D. So I will continue with those 2 mark and 3 mark problems in the next session, and we can meet in the next session, that is tomorrow. So what is the better time to put the class? Evening is good or morning is good? Quickly tell me. So 2 mark and 3 mark important problems I am going to discuss from tomorrow in the 3-dimensional geometry. That will be very important for your board exams. So quickly tell me, all of you, which is better, in the evening or in the morning? One says evening, another says morning, another one says anytime. Okay. So I will try to take the class in the evening only, so that all of you will be free and you can attend the class. Okay, so I will take in the evening, but I will try to put the class at 9 p.m. I will try to put the class at 9 p.m. Then all of you will be very much free at 9 p.m. so that you can attend the class. Okay, no problem. I feel that 9 p.m. was very good because at 9 p.m. more than 50 students were attending the class. See, at 7 p.m. only there are 19 or 20, 22 students in the class. So that's why I will take from 9 p.m. from tomorrow. Okay. So thank you everyone. Be safe and be at home. Clear? Okay. So at 9 p.m. only I will take the class.